Guys, we'll understand what diode transistor logic is. Okay, so diode transistor logic. So we have circuits in DTL built with diode, resistors, and transistors. So these are the three devices that are used to build a diode transistor logic. And the main component that is required is diode. What does the diode do? It speeds up the process. Got it. So one more thing that we have to learn about diode is forward bias and reverse bias. See, this is the pictorial representation of a diode. So we have a small triangle and a small line. So this line, it represents the cathode. This line represents the cathode. At the base of this triangle, it represents the anode. Now, when my diode is in this direction, okay, pointing towards the left, when my cathode is towards the left, and if I'm going to send value 0 into the cathode, then the status of my diode will be on. Similarly, if I'm going to send 1 into anode of the diode, then what will happen? The status of this diode will be on. Similarly, what happens in reverse bias? In reverse bias, so this is my diode, this is the cathode part, and this is the anode part. If I'm going to send 1, the status of this diode will be off. Similarly, here if I'm going to send 0 into the anode, the status of this diode will be off. Okay, so these are two things that we should know about diode. Now coming to NAND DTL, this is the circuit diagram. So we have 4 diodes, DA, DB, D1, D2. So if I see this DA and DB, it is kept in the opposite direction. So remember that. And after that, we have D1 and D2 kept in the normal direction, where we have the anode this side and cathode the other side. Then we have two resistors, R and RC. Then we have the transistor Q1. So this is the base, the emitter, and the collector. And above this transistor, we have the output. Y is our output, and VCC, this is our current supply. And these are our inputs. A, B is the input, and Y is our output. So this is the design of the NAND DTL. Now we will understand how it works. Now, if I'm going to send the values 0 and 0 as input, A is equal to 0 and B is equal to 0, what will happen? My 0 is going into the cathode. So that means this diode will be in on state. It will be in on. Similarly, here 0 is going into the cathode. So DB will also be on. Again, 0 is here, 0 comes here. 0 is going into the anode of D1. What will happen? If it goes into the anode, it will be in off state. So D2 and D1 both will be in off state. Since I don't have anything going here into the input of transistor Q1, that also will be in off state. Off state means it is not short circuited. Okay, so now when all these are off and when DA and DB alone is on, what will happen? The current supply, it goes from here and it will directly go into Y. Okay, since I don't have the connection to go into ground, so all my supply will go to Y. And what will I have? I will have a high value for Y. All right. Now coming to 0, 1 and 1, 0, the similar operation happens. For 0, 1, if A is 0, what will be the status of DA? The status of DA will be on. If B is 1, what will be the status? It will be off. Okay, so if this is off, what will happen? Anyway, 0 will go here. So if 0 goes here, what is the status of D1? D1 will be off and D2 also will be off. So Q1 will also be off. So if this is off, what will happen? Again, my current supply from VCC will go to Y, because this Q1 is not short circuited. It is open. It is kept open. So again, my Y value will be 1, which is high. All right. Now when my A is 1 and B is 0, if my A is 1, if I'm going to pass 1 into the cathode, what will happen? This will be in off state. If I'm going to pass 0 into the cathode, on. So anyway, 0 is going to pass here. What will be the status of D1 and D2? It will be off. Since this is off, that means why am I getting this off? Because I don't have sufficient voltage to switch this on. Okay, because part of my voltage is trapped here. Okay, that is what is happening. So again, since both these diodes are off, the transistor also will be off. What will happen? My VCC, the whole voltage will go into Y, and again my Y will be high. When my A and B are 1 and 1. So if I send 1 and 1 here, what will be the status of DA? DA will be off, DB will be off, because sending 1 into cathode, it is off, right? Okay, so both these are off, so I won't have anything passing here. So if nothing is passing here, what will happen? The voltage from here, part of the voltage from here will pass into D1, all right? Part of the voltage from the supply will pass into D1, and the D1 will be triggered to switch on. So D1 and D2 will be on, because I have sufficient current coming from VCC to switch this diode on. So since I have voltage passing through here into the transistor, what will happen? The transistor Q1 will also be on. So if my Q1 is on, what will happen? This circuit, this Q1 transistor will be short circuited. If Q1 is short circuited, the rest of my voltage, okay, it will quickly come down into the ground. It will be pulled down into the ground. So what will happen? My Y value won't get any supply. That will become low. So it will be 0. Okay, it will be low and 0. So that is how NAND logic works in diode transistor logic. Now we will understand DTL NOR. So this is the circuit diagram for DTL NOR. We have two diodes, DA, DB, and we have one transistor Q1 and a resistor R. Okay, so both these diodes are connected parallelly, and the output is directly sent to the transistor. We have the supply on top, and it is grounded below the transistor. A and B are my inputs, Y is my output. So now how does it work? If my value A is 0 and B is 0, what will happen to my DA? So if A is 0, what will happen to DA? DA will be in off state. Similarly, my DB will be in off state, since B also has 0 value. So off state. What will happen to Q1? Since both are off, this Q1 also will be off. Nothing happens. Off. So I won't have the supply going into the ground. My supply will directly go into Y. So my Y value will be high, which is 1. Now, if my A is 0 and B is 1, A is 0 means the state of QA will be off. You're able to understand? 0 is going into the anode. Okay, so it is off. DB. 1 going into anode, my switch, my diode will be on. Then if this is on, what will happen? We will have Q1 also on. So if this is on, Q1 is short circuited. If Q1 is short circuited, what will happen? My current supply will directly go into the ground and I won't have any voltage going into Y. So my this will become low. So my output will become low. Similarly, when my input is A is 1 and B is 0, if it is 1, my DA will be on. If this is 0, my DB will be off. So even if 1 is off, what will happen? I will have the other supply going into Q1, triggering it and making it short circuited. So since Q1 is short circuited, it means it is in on state. The switch is on. So all my current will flow into the ground without having any voltage for Y. So again, the value of Y will be low. Now when A is 1 and B is 1, what will happen? When A is 1, B is 1, DA will become on, DB will be on. When both are on, I will have voltage flowing into the base of Q1. So when voltage flows here, what will happen? Q1 will be short circuited. If Q1 is short circuited, I will have the supply going into the ground, pulled by the ground. So I won't have any value, any voltage going into Y. So what will be my Y? My Y will be, so this will be on and my Y will be 0, which is low value. So this is how the DTL NOR circuit works.